Alright, exercise 40, which actually has a name to it, but I have no idea what that means or what its importance is. So, we're going to prove this thing. So, let's first let k be some element of n. This is basically a whole bunch of uniform boundedness principle. So if the supremum of all j in the natural numbers of tjk, jk lol is finite, then for all j in n, and let's make that not look bad. So for all j in n and x in x, what do we have? We have tjk of x is less than or equal to the supremum over all j. I'm just going to write that. tjk times the x. And so that's certainly, if this thing is finite, then this is a product of two finite things once you pull the x out, and so this is finite. Which contradicts our premises. Which one in particular? This one. The one that the supremum of this thing is infinite. So thus, the supremum over all j of tjk equals infinity. And again, this is for a fixed k, and we're going to keep it fixed for a while. So now let's look at the collection of tjk of all j in n. Each of these is a element of Lxy, so this is a subset of Lxy. So, by the by uniform boundedness principle, if the supremum, what does the uniform boundedness principle say? It says that if this supremum is less than, so this is a supremum over all j and n of this thing is finite for all x in some non-meager subset of x, then we can conclude that the supremum of the tjk's in norm is finite. But, so here, this is a supremum over all j. But this supremum, we know, is infinite. And so what does that mean? So the set mk, which we're going to find to be a collection of all x and x, such that the supremum over all j of tjkx is finite, must be meager. What does that mean? So for all k and n, mk is a countable union of nowhere dense sets. But then the set M, which we will define to be the union from k equals 1 to infinity of mk, is meager, because it is a countable union of countable unions of nowhere dense sets, and countable unions of countable unions are countable. So this is meager because it's a countable union of nowhere dense sets. So this is meager. So what does that mean? That means so M is not X, since X is Banach. And Banach means it can't be meager in itself. Hence, there exists some element x in x mod m, which is the same thing as saying there is an x in x, such that for all k in n, supremum over all j of tjk of x is infinite. And look, that's exactly what we decided to show. Alright, well that's my 9th problem of the day, and my computer hasn't exploded, so that's probably a good day. And this is a good proof to end on. So, there we go. We've done this proof.